Okay, third question. And those of you who know me know that this is one of my favorite things. Fairly straightforward. Treat it as a sort of intellectual puzzle like Sudoku. Also, this is, for those of you in lab, pretty much all you're doing. Okay, place to start. Those of you with experience with his exams from last year should realize that if he says hint, do it. So let's start there. You should know, and if you don't know, he gives it to you, the equation for finding the degrees of unsaturation. So 2 times the number of carbons, plus 2 minus hydrogens, and minus halogens, and plus nitrogens, but because our formula here doesn't have that, we don't need to worry about it. Divided by 2. So, that's going to be 2 times 5 plus 2 minus 10. So, these guys cancel out. We're going to have 2 over 2. We have 1 degree of unsaturation. That means 1 ring, 1 double bond, 1 something. I'm going to write that up here. Set it aside, we'll come back to it as we need to. Okay, what else does he tell us? He tells us that there is a strong absorption in the range of 1700. What does that mean? That means a carbonyl. So, we're going to say, we know we have a carbonyl. And that takes care of our degree of unsaturation. Let's subtract a carbonyl out of our formula. This is a very good bookkeeping strategy because it helps you keep track of what you have and what you have left to figure out. So, C4H10O. Let's look at our H&OR spectrum, which I have put into the sort of table format that I find very useful for figuring these sorts of things out. Some of these are going to be a little bit interesting, but we can say right off the bat, we have this guy here is an isolated methyl group. So he's going to be a CH3. Let's subtract that out of our formula. And down here, we've got another one. Isolated CH3, that is. Yes, we can get data out of what their chemical shift is, but we're not going to look at that right now. We're just trying to figure out what pieces we have, and later we'll use the shift information to tell us where they go. So we have another CH3. Subtract it out. Okay, so now we've taken care of our 2 CH3s. We've got our 2 CH2s left to take care of. They're both a triplet, so right off the bat, what this should tell you is that they are coupled to each other, because there's literally nothing else for them to be coupled to. Subtract our ethylene out, and we're left with just an oxygen, which tells us, hey, we've got an oxygen. Those are all of our pieces. Count them. 1, 2, 3, 4, 5. 5 pieces. That's taken care of our entire formula. You should get to this point before you start trying to put things together. Okay, having gotten to this point, what do we look at? We look at the fact that these two are both isolated and that they have significantly different chemical shifts. One of the numbers that I know in terms of chemical shifts right off the bat is anything in the vicinity of 2 is attached to a double bonded carbon. So I'm going to guess that this methyl group here is attached to our carbonyl. So I'm going to take away our bookkeeping, and I'm going to say that this guy plus this guy equals that. Okay, so that takes care of that piece, and that takes care of that piece. We now have another isolated methyl group. We've got an ethylene, and we've got an oxygen. Can we stick our other methyl group onto the other side of the carbonyl? No, because then we wouldn't have anywhere to stick these guys. can we stick our methyl group onto the ethylene? Some of you might be tempted to try this. You should pay huge amounts of attention, though, to the fact that this guy is a singlet. He absolutely cannot be attached to our ethylene, because if he were, he wouldn't be a singlet. Now, where does that leave him to be attached to? Our oxygen. Does that make sense? Look at the chemical shift. What is this in the region of? And this should be something that you are familiar with. You don't need to know exact numbers, but generally anything between 3 and 4 does make sense for hydrogens attached to a carbon attached to an oxygen. So, we can put these two together. And at this point, there is no other way we can put this molecule together. Our ethylene has to be attached to our carbonyl on one side and to our oxygen on the other side. And voila, your molecule.